Hey, it's Norm from Tested.com. This is what you're waiting for. We're here at GDC 2015, and I'm in the Valve booth. I'm speaking with Ken Birdwell, who's an engineer at Valve. You have been working on this thing, which is your VR headset, for a long time.
You bet. The whole team has been working on it. Years and years of work. It's been amazing.
So what you're showing here today is actually a first public demo. We've heard stories of the QR code room.
Yes.
You guys have demoed people in.
Yes,
and
yes.
I'm sure you guys have experimented with different tracking technologies, but this is something you're settling on, which is a laser-based tracking technology.
Correct. So what we were looking for was a system that had a high degree of accuracy, super low latency, high precision. The QR code, the room markup, it was wonderful, but it's totally impractical. Nobody's going to do that to their room. So this was a system we started developing a few years back. It's based on lasers. We have 2 beacons in the room. They scan the room with a laser. The sensors pick it up. We based all of that on timing information. From the timing of when the pulse hits you, we know exactly where you are.
Is that similar to something like LiDAR, like for self-driving cars?
Very similar. LiDAR uses a camera. We don't actually use a camera. We just have, those are just little photocells. They just detect the pulse of laser light as it goes by, but we detect it to a really high degree of timing accuracy.
So, because it knows where the base stations are, where they are relative to each other.
Right, but it also knows where all the sensors are. We know the geometry of the headset to within a fraction of a millimeter. So as the laser scans it, the timing differences between when the laser hits it tells you exactly how far you are from the laser and where you are in the room.
And so the positioning, the relative positioning of each of these sensors, super important.
Super important. We actually have a bunch of algorithms which will go through and take a CAD model and do an optimized placing of where all the sensors go.
Wow, so we were talking to Gabe earlier, and he kind of made it the allusion to being like building a virtual map of your environment. Like when you have the base stations, it kind of knows the geography of the room.
So the chaperone systems do a bunch of those sorts of things where once we know where you are, we know where you're looking, we know where your hands are, we can use that information to start to recreate and start to tell you about where is a safe place to walk, where are the walls. You can tell us that information. And then because we know all that, we synthesize all of that information together when you're playing the game, when you're inside. So if you get too close, we start to fade in the wall, we start to fade in your couch.
This is the Star Trek holodeck problem. Well, like in the holodeck,
I don't have a tractor beam, so I can't move you.
So, or a treadmill?
Or a treadmill, but until we do, what we're going to do is we're going to allow you to walk around in a space a decent size. Move the couch, move the coffee table out of the way, walk around, but the game still knows you have physical walls. It still knows you're there. So as you get too close to something, there's an automatic system which kind of fades the real world in.
It's like a ghosting of that wall.
It's like a ghosting of that wall. And so as we design our games, what a lot of the times we do is we'll design a small area where you walk around with. And then if you need to move a far area, move somewhere class, whether teleport you, or there's a dozen different ways of having you navigate long spaces rather than just a small area. You can only walk around in a small area physically, but the game can, of course, I can play with scale, I can play with velocity, I can teleport, I can do all sorts of stuff. And we've used a dozen different techniques to move you around in a game world.
It's a whole different way of thinking about level design and game and storytelling when you're actually moving through a space.
We've done a dozen different experiments, and some of them are just mind-blowing. One where we're in a space and it's full size, and you click a button and suddenly it's a toy version of it. And you move around in the toy version because it's tiny, and you can move so much faster. And then once you're there, you push another button, and now you're back in the real world. I was doing this and having a ton of fun. I took the headset off and said, oh, I want to go back to my desk. And realized, oh wait, I can't anymore, I have to walk. So VR is tons of space. It gives you lots of freedom to move and move around in the world that you've never had before. At the same time, because it's room scale, I can still walk, I can still lean over something, I can still walk up close. It's just amazing.
Now this type of positional tracking is something that you're opening up to other people to develop.
Correct. So we developed all the base technology, we own all the designs for it, but something like this is a little bit more complicated than we can build ourselves. And so what we're doing is it has so many more uses than just games. So what we're going to do is we're going to open this up, license this out to other companies. We would love to see it in all sorts of other devices, love to see it on different kind of controllers, love to see it on different headsets. It's just a general way of tracking in a room-sized space to a sub-millimeter accuracy, high speed, high precision. It's more uses than just games.
But you guys are focused on making games, and games need controllers. So
Correct.
there are controllers here that we use. The ones we use in the demo room were tethered.
Right.
The goal is to have them be wireless.
Correct. So the tethered versions were, okay, the very first version is literally a Steam controller, and we chopped it in half.
So the new Steam controller, which has the actuating touchpad.
Correct. So we used that design, and the team has spent like 2 years on that, and had just the perfect ergonomics, perfect everything. So we took the same designer, said, hey, I'm gonna help you guys out. She came over, she started building it. So all of the nice things we liked about the Steam controller, we incorporated it into this, and on this we then put tracking puck. So we now know where that one-handed Steam controller is to the same level of accuracy as your head.
So you can use it as a pointer.
Correct.
You can use it as a one-to-one thumb
One-to-one, it's anything. The crazy bit is once it's in your hand, it has a display on it, and a screen, and a pop-up window, and it can be a gun. It can
be a portal gun.
It can be whatever you want. Once you're holding this thing, in VR, when you look down at it, I can make it look like whatever you want it to be. And so what we needed was a very simple, very intuitive, very flexible controller. We took the Steam controller because that thumb pad has just so much flexibility in what it is. It can change per game, it can change per mode. And so having this super flexible controller, both hands, move them around, I know exactly where they are, I know what you're doing, has a couple of buttons on it. Tons of possibilities.
Now it seems like tracking was the thing you guys spent the most time on, but there's also the display and the
display ergonomics. There's endless bits of technology here, all the way from the optics to the panels, to the tracking, to the touchpads, to the feel, to the weight, to the power, to the. We've made dozens and dozens of different circuit boards, different designs, different. We've iterated on this well over a year now. Just refining it to the point. The big part for us was getting the game teams inside of Valve involved early. At some point, technology has to do something. And the big thing for us was getting very experienced game designers from inside the company, folks who had worked on Portal and Counter-Strike and Team Fortress, all this stuff, getting a big group of those together, coming down into VR and saying, okay, now what? How do I make a game with this thing? It's a cool toy, but that's not enough. I want to make games. I want to make actual applications. I want to give this to somebody. I want to put this in the hands of a player. What do I do? And so the team started developing. We would try to do something and then hit a roadblock, and we go like, we just can't do this, or we're frustrated, or whatever. And with the hardware teams there, we have the 3D printers, we can do our own circuit boards, we have our own little fab shops. Like week to week, day to day, we would get updates, we would try them out, the game teams would try them out. If it doesn't work out, we could feedback cycle. The next week, we'd have something new.
So what we saw here in terms of you guys using, for example, 2 displays, 2400 pixels wide, 90 hertz, that's like a bare minimum standard.
We feel that's the spot where you really start to get presence, where the world is solid, where you believe you're there, parts of your brain just accept it's real. We think the fidelity this is kind of the bare minimum fidelity, the bare minimum speed.
It can run on PCs.
It can run on PCs, and number one, but it's still a really hefty system. If you think about 90 hertz at that resolution, that's a 4K monitor plus. That's a big screen. You need kind of a beefy PC, so we're kind of at that spot right now.
As an engineer, what are the big challenges that you think should be tackled next in terms of VR?
Near term, far term?
Yeah, both.
God, far term, I have no idea. Near term, higher res displays, lighter weight, less power. There's just endless engineering things to do. Ergonomics, can you wear this thing for how many hours? Makes sense. Sometimes we hear people playing Dota for like 12 hours at a time. Oh my God, okay, that's a tough challenge of having something on your head. What does that look like? There's so many different things that HTC is trying to solve that we're pushing on as well. They're pushing on it. There's going to be a lot of activity in this space in the next couple of years.
And this is the developer kit that will be out soon?
Springtime. So these are our wireless controllers. These are our VR base stations. They are the ones which scan the room and cast out signals for both the controllers and the headset to pick up.
And that headset will be out later this year?
Holiday season. It's going to be up to
season.
HTC. They're going to be the ones manufacturing it. They have the expertise. We're following their lead on this.
I look forward to the games.
The games are amazing. We've seen a bunch of stuff. We've had a lot of great partners here at GDC. everybody's working on stuff. Everybody's trying to figure out what the space is. There's no word for it. I'm both super excited and terrified all at the same time, because every time I look at this, go like, I have no idea what to do next. Nobody solved this problem. It's the Wild West. For me, I did games back in the early 80s, and like nobody knew what games were supposed to be, and so it was this Wild West. And then, I don't know, last couple of years, they're amazing, but I kind of know what to expect. I'm not surprised. In VR, every day, every week, I'm surprised. And every day I look over and like, oh my God, you're the first person to ever see that, ever in the world. That new thing.
It's so exciting.
It's mind-blowing. I'm just like, every week something new comes up. And first you panic, and then you just start giggling. Because you come up with a solution, and it's something new and amazing.
Well, thank you so much, Ken, for chatting with us about your VR system, about SteamVR. We're going to go check in with Will. We both got the demos, and we're going to talk about our experiences, so stay tuned.
Thanks, man.
Thanks. Thank you.
Norman Chan, I feel like I've touched the future.
I know we say that a lot,
Yeah.
but I think the hype really is warranted.
This is, previously I've had tastes of presence. This was full-blown, nothing but presence, almost the entire time. The only time it broke was when I intentionally did something that I knew was going to kind of pull me out.
So let's quickly cover,
Yeah.
we had a conversation with Gabe Newell. Steam machines are launching later this year. They have something called the Link, which is a $50 box. It's exactly like what you built that Nuke box for in-home game streaming, SteamOS. That, I think, is going to be compelling.
It's the thing I've been waiting for, right? I don't need a big heavyweight PC to just stream games from my gaming PC in the bedroom. What I really want is a little tiny, low power box that has dedicated hardware, has a couple of ports to plug a controller into, and lets me play games in the living room with very low latency.
We also saw the near final version of the Steam controller. Different from last year, they added an actual thumbstick on the bottom left. It still has two actuated thumb pads. These are the circle pads that give you the feedback. The left thumb pad now actually has a stencil D-pad style, so it gives you
A huge one, too.
A huge one. I think that's a good design. That's also going to come out later this year for $50. We'll work with SteamOS, we'll work with your PC. But they took that technology and basically put that into their SteamVR.
And the actuator on the D-pad, it's important to note, you can actually feel the D-pad when you're using the controller. I think the addition of the stick is really, really good. The VR is, I honestly, I don't care about anything that I saw before I saw VR at this point. I just want to go back in there and do that more.
Let's talk about VR from
Yes.
two positions. There's one, which is what everyone knows, the headset. So they're partnering with HTC for the displays and the head tracking. It's 2,400 pixels wide with two screens, which is more pixels than 1920. Still 1080 tall. I think that's fine. It doesn't look like they're using the frontal lenses or any of that.
They are using frontal lenses.
They are?
Yeah,
Okay,
absolutely.
so
You
it's
can see the
frontal
frontal lenses. They're an OLED screen. It's a very low latency OLED screen. It seemed like it's kind of hexagonal pixels. I couldn't really tell for sure. The lenses kind of blurred everything out a little, just enough that you could see screen door, but you couldn't really discern screen door. At least I couldn't.
90 hertz, which is good enough for this presence idea, which is less than the Sony experience. I don't know if you noticed a difference.
I didn't notice any
120.
appreciable difference.
Okay.
I feel like a lot of the difference is going to be in software and how it interprets your movement. All of the stuff that we saw in this was one-to-one movement, so if you moved your head, it moved the exact same amount in game.
And then in terms of field of view, we were hoping for ultra-wide field of view. It's not ultra-wide. You still see the edge. I think it's wider than Crescent Bay.
It's much rounder though. Like it looks like you're looking through a small tube rather than a kind of widened oval, which I thought was surprising given the fact that they're actually doing two panels and kind of doing all the right stuff. I'll tell you, I lost focus of the field of view. That's 3 seconds in.
That was it. So all these technical things that we kind of nitpick about in terms of HMDs, the resolution, the screen door effect, the field of view, none of those really matter when you get to the content, and it's really the content that shines because we got lost in that space.
So the other thing they're doing that's different from everyone else is their tracking system uses lasers. You put lasers in opposite corners of the room, and then basically there's a ton of sensors. There's those little chip-looking things on the display. The lasers are each coded, each pulse is coded, and it can say, okay, I got this pulse here, I got this pulse then, I got this pulse then, and if 4 or 5 photons, lasers hit the sensor, each sensor acts as a GPS device. So what instead of having 2 or 3 points of reference as you do with the camera. With this, if they have 3 sensors that each have 5 or 6 reflections, then it's really much more simple math to tell the position and orientation of the headset, and it's faster. It's 100 hertz for the updates.
Think of this, Oculus, what we've seen so far, who knows what they have now, their positional tracking system is IR lights out with camera here. This is flipped, camera sensors here, and lights, not IR lights, laser light pulses coming this way, and all the math
infrared lasers.
All the math being done in the back end.
Yeah. When I spoke to someone afterwards, and he basically said, look, the math on this is a lot easier than doing a lot of vision processing and stuff like that. Basically, it's just, hey, how long did this pulse take to get? How much did this pulse take to get? How long did this pulse take to look? Figure the speed of light, and all of a sudden you know exactly where that sensor is in relation to the 2 rooms. The other interesting thing about that is because the lasers are essentially dumb, you plug them into the wall and they just blast lasers everywhere.
Yeah.
You can use multiple headsets in one room with 2 lasers.
Or you can add more of the laser, lighthouse, laser projectors, spinning wheels, and then you can map out more than just one room.
Exactly. You can connect rooms to each other. You can add, because the math is computationally cheap, you can add more sensors. So you can have sensors on your controllers, you can have sensors on your feet and legs, wherever you want to have them. And they didn't talk about upper limits for that, but I got the feeling that the upper limit for the number of sensors you can have in the room is very, very high.
Now, they didn't let anyone take photos or video of the demo, so we'll have to paint a word picture for you.
I'll super.
Yeah, that's what it looked like, basically, the entire time. You were put in a room, there's a tech in the corner, you were still tethered, both in the controllers, which will be wireless in the final version, and the headset. But something that they did was also put a brace on you for cord management.
So this was really helpful, and it meant that the cord management, instead of being a full body problem, was basically just a foot problem.
Yes.
A couple of times I would ask the tech in the room and said, hey, am I tangled up? I feel like I've got something on my left foot. And he'd say, no, shake it a little bit, and then I was clear.
And because they know the room, they kind of mapped out the room, the boundaries, as you got close to a wall, on screen, regardless of what demo you were in, there would be this holographic overlay, as if you were seeing the edge of a holodeck in Star Trek pop in over the scene.
Alpha'd into the scene, so it doesn't really take you out that much.
But it gives you an awareness of where your natural boundaries are.
So did you, by the end of the first demo, I had completely lost my orientation in the room, which doesn't really happen for me very often. Usually I can say, okay, that's north, I know which way that is. It was a little discomforting.
Yeah. So one of the first demos, they kind of ease us in. And Valve does a really good job of easing people in the demos. One of the first demos, blank room, kind of a blank slate. Then there was you're on the deck of a ship, and the bow of the ship kind of matched the edge. You never want to walk past that anyway, but you were free to walk around this entire sunken ship. And then when a whale came over and came right in front of you, you could then peer into its eye, or look over the edge into the abyss and try to get that Virgo effect.
So the controllers, most of the demos didn't actually use the controllers. That first loading room did, the white room is what I think they call it. And the controller has a couple of different inputs. There's a trigger, just like a Move controller. There's the Steam controller actuators, like thumb pads, basically. And then there's a grip squeezy thing. So you can click the thumb pads, you can squeeze the grips, you can pull the triggers. Most of what we were doing today used the triggers. There were a couple of things that used the thumb pads in like radial menus and stuff like that. I thought that was a really high-powered way to work with the VR.
Yeah, the demo where you're painting a room, and you can actually, the controller isn't just like a laser pointer paintbrush. By rotating the controller, there's almost an augmented reality menu that goes around, that pops up, and then you use the other controller to point at the item.
You could spin that. So yeah, there was a triangular shape, like it was almost like a box that you put around a microphone. It spins. On one side is color selection, on the other side is brush selection, on the third side is like save, delete, reset, all that kind of stuff.
And then as you were painting in 3D space, you could then walk around the painting. It would be still through the painting, look at the painting from all sides. It's a 3D painting, and that really enhanced the sense of it being a space.
So for me, I painted all around myself in a sphere, and then the guy in the corner said, hey, why don't you step outside and see what you've done? And it was a whole different perspective. But you're literally painting by putting the tip of the controller here, and going sideways and then up and down, however you want in 3D space. It's pretty amazing. I think that was probably my favorite part of the whole experience.
Fantastic demo. There was a Google Earth demo. They were streaming Google Earth, so you felt like Godzilla, and you could look around, and all the details of the buildings were there. The end of that demo, you saw the Earth, and it felt like you were Superman floating in space, staring at the globe, and then flying in. That's going to be incredible. One of the demos was actually, it required more dexterity. It was a cooking demo.
It's called Job Simulator.
Right, so it's a futuristic job simulator. You're supposed to make a soup by picking up items. This is the first one I thought it needed better precision in terms of selecting the objects.
So one of the things,
these weren't tongs.
Right, one of the things that changed in each demo is the representation of the controllers. So on the loading screen, it basically looked exactly like the controllers, except for one would spit balloons and the other one would do something else. On the job simulator, you just had kind of fat hands.
Yeah, fat hands.
And they were sticky, not really dexterous.
Yes, and they were the items on the table, the bread, the soup, the tomatoes would glow. So it was a more traditional,
very much like the move,
glowing, and then you would then lock it into your grip. But you could do cool things like pick up a knife and then try to cut something, and the knife would shatter.
Did you cut the carrot?
It shattered.
I cut the carrot. Then it shattered.
And then finally, the Valve demo, everything built up to this Aperture Science demo, which is like Portal, but first person, but really first person.
Like
and this
the firstest person.
Expanded, it was unbelievable. This was basically gaming. This is a future game.
Yeah, it is the future. Like the future of gaming is not too strong a terminology. I mean, we tend to be effusive. This is the best VR demo I've ever had.
Yes.
Seeing the demo with narrative elements, seeing VR with narrative elements and laid in, and seeing characters and hearing voiceover and getting general direction adds so much to the experience over just, here's a cool scene that we made.
And a lot of it goes to the game design. In that demo, you're in a room much shaped like the actual demo room.
Yes.
So, for example, the Oculus Crescent Bay demos, while I did feel presence, for example, the subway station demo where the T-Rex comes at me, I'm never going to the edge of the walls. I'm never going up close.
I'm afraid to go to the edge of the walls because I'm afraid I'll hit myself.
Right, and for that one, you had a limited boundary. Here, you had this several foot by several foot space. You could go up, you were encouraged to, as part of the story, to go up and open a drawer and then look inside and peer. A robot, Atlas, comes in to the room and you do things that you couldn't
You
ever do.
literally, like, the setup for that was, here's some stuff you need to do in the Aperture universe. So you have a kind of passive-aggressive computer telling you what to do. The first thing you do is pull out some drawers. You have representations of the controller in each hand. You can see them. They move in like, the fluidity of the movement of the controllers in front of you was something that I haven't experienced in other demos before. Like, it was incredibly precise movement, and it mapped perfectly to what I was actually doing. Like when Atlas, was it Atlas or Peabody? It's Atlas?
One of those.
Yeah, but one of the robots when the co-op Portal 2 stuff comes out, you have to fix him. And the first thing you do is grab a handle and then stretch him all the way out as if he's an exploded diagram of what that robot is. And then it gives you all this cool VR, AR overlaid stuff to fix the robot. It was like the potential for storytelling in that is really, really astounding.
And I think it makes the more use of assets that artists create. For example, in Portal 2, the opening sequence is this crazy, like almost scripted sequence. But the Valve artists, level designers, had to build this entire infrastructure that you really only see for about 10 minutes. With VR, in this demo, you're gazing at that. And the head is less a control mechanism. Like you're not pointing to shoot things or looking at things to activate. The head is a passive absorption tool. It's a display.
It's literally, you're using it the same way you use it in the real world. You're using it to get a better look at things you want to see more about.
And so you're not straight to your neck, turning it, looking around constantly, because that's not part of the design. Game developers have to learn that, and they need a system like this to enable that, so it's not just rotational movement for control.
So let's talk about a few things. Everything was one-to-one movement, I think, that I saw. They had a couple of different demo loops. I think developers got to see something different than we did.
And everything being one-to-one movement doesn't have to be the case.
No.
That can be a thing that they change with scale to make your 10 by 10 room actually look like 100 by 100.
And I mean, they even have things like snap turns in some of the games that they didn't show us today, where you hit a button on the controller and it does a pivot turn rather than a the slow one-to-one turn that you do in VR. I found myself pushing the boundaries. I did bump into the wall once. The grid, the hey, you're about to hit the wall grid, pops up a little bit slower than I was moving at the time.
It also didn't
tweaking
track
that.
the controller yet, which it will.
Oh, okay.
So that's going to be something the grid will pop up.
Oh, when you put your arms out. Oh, didn't catch that.
I think that one of the biggest takeaways for this is that we should get less hung up on the display technologies. That stuff will get better, the optics, displays, but it's really about the tracking. And what they demonstrated here is tracking beyond a camera pointing at IR.
So a couple of things. You tend to get motion sick. Any hint of that? The demo's 18 or 20 minutes long.
Did not. No motion sickness. Completely lost, believable space. It's not photorealistic in terms, it's not going to be your however many lines of resolution you need to actually convince
It's not a 4K panel, but
it's the same as this, but the sense of place is absolutely there.
So Norm, I'm not super sold on the idea of putting the laser sensors in the corners of my room. Like I have a small house in San Francisco. I don't have that much open space in my house to do this. So I really enjoyed the experience. I don't know that it's going to be real in the real world.
That's a very good point. Most PC gamers are at their desks right now. Their Oculus DK2 systems work because they can put it on a tripod, camera, and you can.
Or just on top of your monitor.
Or some positional tracking. But this is something that I would dedicate a room to. I would dedicate a room.
You have a different set of priorities than maybe some people, but it's an amazing experience.
It's one step closer to the holodeck.
I just want the couch with the tubes and the Soylent, and I'll just jack in and I'll be virtual forever now.
So this is actually the last demo we did today. We'll have more stuff from GDC 2015, taking into account all that stuff we saw before today. But find more stuff on Tesla.com. Subscribe to our YouTube channel, and we'll see you next time.
And if you want to see total wrap up about the entire day, we're going to do a podcast addendum right after this and put everything in context. So see you guys later.
Bye.
Bye.